Hello, Ferocious here. In previous video we have seen how to install GnuRadio using precompiled binaries. It was pretty straightforward, so let's go ahead and launch GnuRadio Companion and talk about what is GnuRadio and what is GnuRadio Companion and how we can use that to develop our software-defined radio applications. So I'm going to type GnuRadio Companion in my terminal, and voila, the graphical user interface pops up. So what is this graphical user interface? In this canvas I can place different blocks, and as you can see, GnuRadio Companion have already created 2 default blocks for me. And usually I'm going to have, if I'm talking about a software-defined radio kind of application, I'm going to have a source of samples and signals, and I'm going to do several different operations on that, modulating, demodulating, things like that. And then I'm going to pass the result to some sort of destination which is called sink. So what is this initial block, default block that is generated by GnuRadio by default for me? Let's take a look at it. It is a representation of what would be the outcome of compiling this flow graph. So GnuRadio is the engine that is behind GnuRadio Companion. We are looking at GnuRadio Companion, and GnuRadio Companion will create a Python file for me that will communicate with GnuRadio itself and do the signal processing in very efficient manners that may not be possible for us if we want to just drag and drop some blocks and be done with it. So in this block, which is called options, we have several attributes that are about the attributes of this flow graph itself. So for example, we have an ID which can be anything. It will correspond to the generated file that this application will be compiled into. That is going to be a Python file that communicates with GnuRadio itself. I can have title, authors, and different descriptions. I can change the size of this canvas that I have available to me to place blocks on it. If my block chains are very long and very detailed, I may want to have more real estate on my screen to place them. So this is the first default block that is given to me. The second one is just a variable, and that variable block represents a name and a value that is going to be accessible to other blocks. By itself it does nothing, but it gives me a single point of entry to change some variable and have that be changed in all other blocks that may use that. And it is more convenient to have it here. Most likely we are going to have a notion of sample rate if we are talking about software-defined radios. Therefore, GnuRadio by default creates this for me. On the right-hand side, we are going to see the categories of blocks that are available to us. There are a lot of different categories of blocks, and there are a lot of blocks inside each of them. For example, in the audio, you can see if I open that category, we are going to be presented with several different blocks that can do different things related to audio. We are going to get familiar with all of these in a series that I'm going to launch, which is called Know Thy Blocks. But for now, we are just going to get familiar with the GnuRadio Companion environment itself, what it does. So I can choose the blocks that are available to me on the right panel, and I can place them on this canvas. And this is the result of the resulting output of the compilation of GnuRadio Companion flow graph itself and the execution of the resulting Python file. I can have a console-like interface here that I can see my loggings, I can see my errors. So we have these three main areas. The other thing is these buttons up here. I can open new flow graphs, I can save them, I can execute and build my flow graph, and different things that are very common to all graphical IDEs. So in short, GnuRadio Companion is a very convenient graphical user interface for me to connect different blocks and have some sort of digital communication or software-defined radio be presented visually and be modified very conveniently, very fast. In the next video, we are going to start a very simple sample exercise, if you will, flow graph, and look at how it can be used to generate fairly powerful flow graphs fairly easily. Thanks for watching.